Hi everyone, my name is Abdullah Batuhan Yorulmaz. I'm second year computer science student at Bilkent University. This is my Physics 102 project. Basically, I'm looking for the effect of a plate area on capacitance. As a summary, I created a capacitor configuration initially that allows me to change the conductor plate size, and the capacitance of each new capacitor is then measured using the same material in various sizes. The measurement will be repeated with the size changed, and the result will be compared to the theoretical values. Finally, I will calculate my average error. So my equipments are multimeter, handmade parallel plate, and the ruler. My theory is the parallel plate capacitor has two identical conducting plates, each having a surface area A and separated by a distance D. When a voltage V is applied to the capacitor, it stores a charge Q. We can see how its capacitance may depend on A and D by considering the characteristic of the Coulomb force. We know that force between the charges increases with the charge values and decreases with the distance between them. We should expect that the bigger plates are, the more charge they can store. So C should be greater for a larger value of A. Similarly, the closer the plates are together, the greater the attraction of the opposite charges on them. Therefore, C should be a greater for a smaller D. So my main equation is C is equal to Q over V, and that is also equal to epsilon 0 multiplied by A over D. So I will use this equation for calculating the theoretical capacitance. So I will conduct my experiment in three parts. I will only change the plate area. So let's look at my experiment. These are my equipments. This is the smallest plate area. So this is the another plate area of my capacitors. And this is the biggest plate area of my capacitor. And this is the multimeter. So this is my experiment. As you can see, I made a parallel plate handmade capacitor, and I'm changing the plate area and measuring the capacitance of the each capacitors. So that's my experiment basically. I made five. I conduct the experiment 5 times for each experiment because for the accuracy. So this is the first experiment. My plate area was 0.01 meter square, and the average of the experimental capacitance is 0.0018 nanofarad, and my error rate is 64%. This is the second experiment. My plate area is 0.0225 meter square, and the average of the experimental capacitance is 0.0033 nanofarad, and my error rate is 32%. So this is the third experiment. My plate area is 0.04 meter square, and the experimental capacitance is 0.0055, and the average of the error rate is 28%. So my plate distance between the plates are same. It's 0.08 meter, and I have errors because the parallel plate conductor was handmade, and there are no proper conditions like temperature and the air. But I observed that when there is a direct correlation between the plate area and the capacitance of the system. So when the parallel plate area is increased, also the capacitance of the system will be increased. So this is the first graph for my experiment. These are the values I found, and this is the average of these values. So this is for the second experiment, as you can observe. This is for the third experiment, and this is the graph. We are looking for the capacitance plot of capacitor compared to the plane area. So this is the first experiment, this is the second experiment, and this is the third experiment. We can observe that when the plate area is increased, also the capacitance of the system will be increased, and this is my best fit line. So thanks for watching.